Hello, today we are going to start the chapter on lubrications. As we have seen in the last two chapters that we have discussed about the frictions and wear. So, now we are going to introduce the lubrications which can reduce the friction in between the mating surface, by which your total loss like in terms of wear can decrease. So, before going to start, first we have to know that what is the lubrications. Lubrications is something like any kind of material which can lubricate in between the mating surface. Either that surface can directly come into the contact, or maybe there is a lubrications which will act in between the two mating surface. So, lubrication is the process or technique employed to reduce friction between surface in proximately and moving relative to each other by interposing a substance called a lubricant. That means, lubrications is the terminology by which it is decreasing the wear, and the material is called the lubricant which is doing the lubrication process. This is mainly intended to minimize the wear or of one or both of the surfaces. When lubrications break down, so the parts will directly come into the contact. So, they will collide each other, they will rub each other, due to that the heat generation will be there, or maybe they can heat each other, due to that the material loss can occur. So, there are several types of problems if the lubrication system will fail inside any equipment or machines. Adequate lubrications allows smooth continuous operations of equipment, reduce rate of wear and prevents excessive stress and bearings. So, sometimes it can absorb the heat, sometimes it can lubricate the material, so that there will be some sliding motion, smooth sliding motions in between them. So, there are numerous applications or maybe advantages we can say it, by which we can reduce the friction. So, what are the objectives of lubrications? The lubrications objectives are: number 1 is called wear and tear of the surfaces, maintenance cost, heat from the bearing, unsmooth relative motions, expansion of metal due to frictional heat, power loss. So, that means if we do not use the lubrications, we can see this type of problem, or maybe we can can't rectify all these problems inside the systems, or maybe inside the metals, or maybe the materials. This is the simple example of the lubrication systems which is acting on any machines. So, from the right hand side figure we can understand that this is one kind of lubrication systems. Generally we are using it for the heavy machines or maybe the rugged machines, but if for the small machines generally we are having some kind of lubricating or lubrication related some kind of can or maybe small gun, by which directly we can put the oil or maybe grease to some mating parts, or maybe to the bearings, or maybe to the pistons. But from this particular figure you can understand that this generally we are using for the rugged machines. Here we are having some kind of engine oil sump. So, where we are storing our lubrications oil, then through pump we are taking out that oil, and then there is certain kind of strainer by which the oil is passing. So, if there is any dirt or maybe particles or maybe any kind of wear debris are present, that can be strained out from the oil itself. Then the fresh oil, again we are applying certain kind of pump by which it can generate certain kind of pressure, so that it can reach to all the corners of the bearings or maybe the machines where there is some relative motions in between the parts. So, oil pump pulls oil from the oil sump, pump pushes oil through the oil filter and cooler coils. Oil filter removes very small particles, because that oil continuously we are reusing, we are not putting the new oil frequently. So, whatever the oil it is coming through from some device or maybe equipment, maybe it can carry some kind of wear debris or maybe particles that can be stored into the oil sump itself. So, while again we are suctioning that oil, again it is going through some strainer so that will take out that particle or maybe debris, and fresh oil can directly go to the mating surface. So, next slide we will see what is the types of lubrication systems. So, from this particular slide we can understand that there are several types of lubrication systems. That means how we can lubricating different machines by different processes. First one is called the oil bath lubrications. This is the common lubricating systems generally we are adopting in our daily life. It is a non-circulating system considering maintenance of proper oil level. So, simply we can see that the lubrications maybe the volume or maybe quantity is going down. So, then we can pour some kind of lubrications into it, so that there will not be any pump or pressure. By normal means you are lubricating the machines. Second is called the wick feed lubrications. Here generally we are using certain kind of cottons or maybe some kind of threads by which your lubrication oil is sucking from the sump or maybe the container, and directly it is going to the machines or maybe the bearings or pistons. Third one is called the deep feed lubrications, dispense oil by gravity at controllable flow rate. In this particular case your lubrication sump is into the top, and by the gravitational force automatically the lubrication oil is coming down and directly it is feeding into the gears or maybe the bearings. Next is called the oil splash lubrications. So, here the oil is splashed. So, here we are creating little bit of maybe vacuums or maybe little bit of pressure, so that the oil is coming through the pipes, then it is totally splitting into in a high form and it is covering the whole mating surface or maybe the in between the interfacing surface it is entering. Next is called the circulating oil lubrications. From this particular you can understand that here we are using certain kind of pump, so that that pump is taking out the lubricant from the sump itself, then it is directly throwing into the mating parts, then again it is collecting that oil lubrications or maybe the oil, and then again it is depositing that into the sump. So, it is a circulatory motions or maybe it is a circulating process. Next one is called the oil jet lubrications, where you are using certain kind of pressures, so that the oil is passing through in a very high velocity. So, the advantage of this that if there is any complex shapes or maybe any complex places where that lubricant can't reach, so that we are giving certain kind of pressure, so that that oil can reach each and every corner. And the last one is called the oil mist lubrications. Mist is nothing but the small droplet. So, with oil we are injecting high air or maybe high pressure, so that like a spray the oil is floating onto the surface. It is not the continuous oil is coming, it is like a droplet, the oil is coming onto the surface in between the mating parts, and it is doing the lubricating or maybe it is using for the best lubrications. Then next one is called the lubrication regimes. So, from this we can understand that there are several types of lubrications generally we are adopting. Based on that, how we are going to lubricate the materials. So, first one is called the boundary lubrications, then mixed lubrications, full film lubrications and extreme pressure lubrications. Then full film lubrications is also divided into three parts. One is called the hydrodynamic lubrications, elasto-hydrodynamics lubrications and the hydrostatic lubrications. So, next slide we will discuss all this. So, first one is called the boundary lubrications. It is the common type of lubrication systems generally we are adopting in our daily life. Maybe the part may not directly contact in between them, they are contacting through the lubricating oil. So, two surfaces are mostly in contact with each other even though a fluid is present. It is observed in machine sideways, lathe cross slide, milling machine table. So, either maybe there is a film in between them or maybe the parts are directly contact, but still your lubricating film thickness is very less in between them. Second one is called the mixed lubrications. In the mixed lubrication systems we can see that the part maximum cases it is not contacting each other, there is certain kind of lubrication films are present. So, from this particular figure you can understand that two bodies is moving into the opposite directions and in between the lubrication is acting. Next is called the extreme pressure lubrications. So, surface under high pressure and speed at an high local temperature due to which lubricant fails to stick to the moving parts. Therefore, special additives are added to oils. These are called extreme pressure lubrications. So, from that particular figure you can understand that bearing is acting onto the metal base. So, when it is rolling, so due to its normal load the bearing is giving a pressure onto the surface, due to which maybe the lubrications in between the bearing surface and your metal base maybe can go out. So, we are using certain kind of additives which can stick the lubricant with the bearings itself as well as with the metal base itself. Next one is called the full film lubrications. From the name itself you can understand that these lubrication systems will act throughout the whole operation process, and not only that it will always cover all the mating parts. First one is called the hydrostatic lubrications, or maybe in another way we can say it called the lubrication is in static. So, that means lubrications is not flowing or maybe not movable. So, here the motions of the contacting surface and the exact design of the bearing is used to pump lubricant around the bearing to maintain the lubricating film. So, from this particular figure you can understand that there is some housing and in which the piston is rotating and piston is having some bearings. So, from this particular figure you can understand from outside we are creating certain kind of channels, or maybe we are making certain kind of piping arrangement by which the constant the lubrication is coming and it is going inside the system. So, here the lubrications actually is not into the moving contact, only it is into the touching contact in between the pistons and the housing. So, there are some disadvantages also for this process. What are those? In hydrostatic bearings, corrosive wear of the bearing surface occurs as a result of interaction of the lubricant with the interface materials. These bearings require high pressure pumps because we have to take that liquid, then we have to throw it in a high velocity, because there is a very narrow gap in between the bearings and the housings. So, that oil should reach in between that space. So, you need a high pressure. And equipment for fluid cleaning, thus requiring large space and it is expensive too. Next is called the elasto-hydrodynamic lubrications. So, from this particular figure you can understand that here the shaft is rotating onto some base materials and your lubrication is coming in one way and it is going into the other way. Means when there is some rotating parts and we are lubricating from a one side, due to the centrifugal force the lubrication will try to go outer surface. So, that is why it is called the elasto-hydrodynamic lubrications. The body suffers elastic strains at the contacts. Here the sudden reduction of the oil film causes a temporary increase in viscosity, because it is acting in these directions, also it is rotating. So, the gap in between these two, in between the bearings or maybe the pistons and in between the surface is very narrow. So, sometimes the thickness of that lubricating film is getting reduced. It occurs in surface in rolling motions relative to each other. It is induced in heavily loaded small contact areas, point contacts of ball bearings and the line contacts of ruler bearings and of gear teeth. And the last one is called the hydrodynamic lubrications. So, from the hydrodynamic lubrications you can understand that here the lubrication itself in motion. So, that is why it is called the lubricant is dynamic over here. So, when an external pressure is applied to the lubricant in the bearings to maintain the fluid lubricant film where it would otherwise be squeezed out. So, we are having some pistons and in between that we are having the piston outer ring and we are having the piston inner ring. The lubrications is acting in between that. So, when the piston is moving inside it, then what is happening actually, the inner wall is like this and inner wall of the piston is like this and the inner wall of this piston hole is looking like this. So, the lubrications is acting in these regions, but sometimes while rotating this is due to its maybe weight or maybe the gravitational force, sometimes it is coming down. So, sometimes it is becoming like this also. So, the thickness of the lubrication film is getting reduced, but again it is rotating. So, due to that lubrications also inside the system is also continuously rotating. So, that is why it is called the lubricant in dynamic motions, and you are having some port over here. So, if the volume of that lubrications is going down or maybe the quantity is going down, so that again you can pour the new lubrication or maybe new lubricating oil inside the system. So, it is the confined manner. So, by which your lubrications is also rotating with the moving force of that particular piston. So, in this slide we will see what is the Strebeck curve. Actually, Strebeck curve will define that whether our lubricant is lying onto some mixed conditions or maybe some hydrodynamic conditions or maybe into the boundary conditions. So, here from this particular graph we can understand that y axis is denoting the coefficient of friction in between two mating parts and x axis is giving the Hershey number, which is nothing but the eta into omega divided by P. So, here eta is called the oil dynamic viscosity, P is called the normal load which is acting onto that surface, and your P is the total load acting on this surface, and omega is the relative viscosity or maybe the relative velocity of the opposing surfaces acting in between the two mating parts. So, from this particular case we can understand that Hershey number is like a number, it is a maybe the which will define that whether your material will lie into different conditions. So, if we draw this curve, so from that particular curve we can calculate the lambda ratio. So, lambda ratio is H is called the what is the height or maybe the depth in between the two surfaces. Okay. So, here or maybe the fluid thickness in between the surfaces or maybe the height means how much it is touch gap in between the two mating surface, that will give you the lubrication thickness. Then sigma 1 and sigma 2 are the surface roughness of these two mating parts. So, sigma 1 and sigma 2 are acting each other. So, from these particular equations we can calculate that what is the lambda value. The lambda value, if it is less than 1.2, then your lubrications will lie in between the boundary conditions. If the lambda value will lie in between 1.2 to 3, then your lubrication will lie on the mixed conditions, and your lambda value will be more than 3, then it will come into the hydrodynamic positions. So, the zone are classified as boundary region, mean thickness of the lubricating film which is lower than the mean roughness height of the opposing surfaces. Mixed lubrications, lubricating film is completely separates the surfaces, and the hydrodynamic lubrication shows continuous lubricating film which corresponds to the optimum operating zone. So, from that particular case we can understand that whether there is certain gap in between the two mating surface or not, whether the lubricating or maybe the film or maybe the lubrication oil is touching the two surface or not, and the most vital thing is that whether the two contact is directly coming into the contact or maybe there is some gap or maybe there is some partial contact in between them. Next one is called the lubricant. So, till now we are talking about the lubrication systems. So, by which we are doing the lubrication systems or maybe the lubricating the machines, that is known as the lubricant. So, lubricant may be in the solid form or maybe in the liquid form also, it can be possible, and nowadays we are using the lubricant in the gaseous forms too. So, it is a substance introduced to reduce friction between surface in mutual contact, which ultimately reduce the heat generated when the surface moves. So, there are several components of the lubricant. Generally we are using the base oil, mineral byproducts of crude oil refining. Base oils are polymerized or synthesized further and called the synthetic. So, there are two types of things, either directly whatever we are getting from the nature we are using it for the lubrication purpose, that is called the natural lubricant, or maybe some lubricant which we are doing or maybe preparing in our labs, then we are adding some additives or maybe some kind of fillers, that is known as the synthetic lubricating oil. So, what are the base oils? So, American Petroleum Institute categorizes the base oils into 5 groups. These all are called the standards. So, first one is called the group 1, that is solvent refined. Its sulfur percentage is greater than 0.03%, saturation is less than 90%, viscosity index is 80 to 120. Then group 2 is called the hydrotreated, where the sulfur content is less than 0.03, saturation is more than 90%, viscosity index is 80 to 120. Group 3 is called the hydrocracked, sulfur percentage is 0.03%, saturation is more than 90%, viscosity index is more than 120. Group 4 PAO synthetic lubricants, group 5 all other base oils not included in group 1, 2, 3 or 4. So, from that particular standard we can see that what is the viscosity of that particular lubricant, what is the chemical properties of that particular lubricant, because lubricant always we are using certain kind of lubricant, that does not means that it will not harm your body. Maybe some lubricant can react with the mating parts too, or maybe can do some kind of chemical reactions in between the mating parts, that also we have to take care. Then come to the next is called the additives. Additives is nothing but the certain kind of fillers. Still now we are using certain kind of virgin oil, but that is also have some limitations. Then we are using or maybe adding certain kind of additives or fillers, so that it can go with the oil to that particular zone, maybe it can absorb more heat than the lubricant oil, or maybe it can cool the system very easily. So, what are those additives? First one is called the antioxidants, added to minimize and delay the onset of oxidative degradations. So, we are adding some kind of antioxidant materials into the oil itself. Next is called the foam depressants, deformate droplets attached to the air bubbles and coalesces into larger bubbles rising to surface as a foam layer, where they collapse and release air. So, they can create a bubble which can hold the air at that particular point, then they will collapse and they will release the air, so that the material will cool down very easily. Next one is called the corrosion inhibitors. From that particular name you can understand that we are using certain kind of materials which can resist the corrosions in between the mating parts. Detergent dispersers are designed to control the deposit formations. Next one is called the friction modifiers, reduce friction and wear, also improve the fuel efficiency, so that we can use that fuel for longer time. Next is called the types of lubricants. So, from this already I said that we are using the lubricant in maybe in normal life we are using into the solid form, but maximum cases we are using into the liquid form, but nowadays we are using the lubricant in gaseous form too. So, liquid, typical lubricant are liquid or fluids, mineral oil or maybe the synthetic oil. So, from this particular oil we are having some very famous companies like Castrol or maybe some kind of Mitsubishi oil. So, they can use, or maybe the Vidol, which are making very good lubrications oil, by which we can lubricating our engines, our pistons, our cylinders, everything. Next, some kind of solid materials like graphite or molybdenum sulfide, which can act at the time of pressure, maybe they can lubricate the systems easily, but they are in solid form. Next is called the semi solid, it is called the greases. Generally in our automobiles parts we are using this kind of systems, and gases, atomized two stroke oil. So, nowadays we are using for racing bikes or maybe some kind of parts which is highly movable, so that time we can use some kind of atomized gases over there for acting as a lubricant. On the basis of source, So, first one is called the animal oils. So, from animal fats we are getting that kind of lubricating oil directly. Vegetable oil, so from the vegetable, from our natures, or some maximum cases this vegetable oil is biodegradable too, so that can't do any kind of environmental hazard. Mineral oils, hydrocarbons obtained from some minerals. Synthetic oils, as I already told, these we are preparing into our laboratory by doing any kind of reactions over there. Grease, semi fluid lubricant, it is also a one kind of synthetic materials. And dry, molybdenum disulfide or maybe the graphite. Dry means these all are the solid lubricants. Now next one is called the impurities and contaminants in the lubricants. So when you are using that lubricants, when it is going into some bearings or maybe the gears or maybe the mating parts, that mating parts is constantly rubbing each other. So due to that frictions, both the material is losing, then some loose materials or maybe the debris that is coming and that is mixing with the lubricant itself. So types of contaminants, first one is called the solid particles, include wear debris which damage the mechanical components. Liquid particles include fuel and water which hinder proper operation of lubricant and its additives, and the gaseous contaminants include combustion products which corrode component surface and break down oil. So that is why each and every lubrications or maybe lubricating oil maybe or lubrication systems has some service life. So after certain time when the properties of that particular lubricant will go down, we have to change that lubricating oil so that it can work properly. Next is called the characteristics of the good lubricant. What properties should have that lubricant so that we can use it. First one is called the high viscosity index. So with temperature also it should not be in the liquid form, or maybe the liquidity nature of that lubricant should be very less, so that it will create always a film in between the mating surface, it will not go out. Flash point should be higher than the operating temperature. Its flash point means its burning temperature or maybe melting temperature should be higher than the temperature whatever it is generating due to the friction in between the mating parts, otherwise it will itself burnt or maybe the melt. Cloud point should be lower than the operating temperature of machines. Due to the temperature it should not be agglomerate. If it will be agglomerate, then it will be very difficult, the lubricant will not pass through all the surface. Volatility of lubricant oil should be low. Carbon deposited during usage should be low. High aniline point, higher resistance towards oxidations and corrosions, deposit least amount of carbon using use, have good detergent quality. So these all are the properties a good lubricant should have. Then in summary we can say that the main purpose of lubrications is just to reduce the wear or maybe the friction in between the mating parts, so that the parts or maybe the surface or maybe any kind of engine or machine life can be increased. Adequate lubrication also helps to prevent foreign material from entering the bearings and guards against corrosions and rusting. Yes, of course, because it will create a film in between that, so that that bearing or piston it will not directly come into the contact to the environment, or maybe it will make a coating so that some other particles or maybe impurities not come directly contact to the mating surface. Satisfactory bearing performance can be achieved by adopting the lubricating method that is most suitable for the particular applications and operating conditions. Lubricating oils are made from the more viscous portions of the crude oil which remains after removal by distillation of the gas oil and lighter fractions. Lubricants do not persist working without additives. Nowadays we are using certain kind of lubrications, not certain kind, maximum cases we are using certain kind of nanoparticles over there, nanofillers over there, just to enhance the properties of that particular lubricants, and a lubricant can work for several machines for several applications. Thank you.